Since the dawn of time, humanity has gazed upward, captivated by the glowing orb that hangs in our night sky. The moon has inspired countless myths, guided explorers, and fueled our imagination for generations. It has always represented a distant, almost mystical goal. A place just out of reach, yet forever calling to us. In the 1960s and 70s, the Apollo missions transformed that ancient dream into reality. With the thunderous roar of the Saturn V rocket, humans broke free from Earth's grasp and set foot on another world. It was a triumph of science, engineering, and sheer determination, a moment that united people across the globe in awe and wonder. Yet, after those first historic steps, our ambitions seemed to fade. The moon landings became memories, replayed in grainy footage and old broadcasts, reminders of what once was. For decades, the dream of returning to the lunar surface lingered, but progress stalled. Now, a new chapter's unfolding. SpaceX's Starship, a gleaming giant of stainless steel, stands poised to reignite our lunar ambitions. Towering over its predecessors, Starship represents a bold leap forward, a vehicle designed not just for exploration, but for building a future among the stars. Starship is more than just another rocket, it's a complete reimagining of how we travel in space. Its immense size and power dwarf previous spacecraft, and its innovative design could make spaceflight more accessible than ever before. Built to be fully reusable, Starship aims to operate more like an airplane than a traditional rocket. Rapid turnaround between flights could dramatically lower costs and increase the frequency of missions, opening the door to routine journeys beyond Earth. The vision is ambitious, to make humanity a truly multi-planetary species. Starship is designed to carry people and cargo not just to the moon, but onward to Mars and even further, turning science fiction into achievable reality. NASA's Artemis program is the next step in this journey, aiming to establish a sustainable human presence on the moon. Artemis will lay the groundwork for future exploration, research, and even potential lunar settlements. In a historic partnership, Starship has been chosen as the human landing system for Artemis. This means astronauts will once again walk on the moon, this time arriving in a spacecraft unlike any before it, one capable of carrying larger crews and more equipment. With its vast cargo capacity, Starship could deliver habitats, rovers, scientific instruments, and vital supplies, enabling longer and more ambitious missions. The possibilities for exploration and discovery are greater than ever. But before these dreams can be realized, Starship must overcome one of spaceflight's greatest technical challenges, refueling in orbit. This complex process will allow Starship to reach destinations far beyond the moon, carrying enough fuel for the long journey ahead. Mastering in-space refueling is the key to unlocking the solar system. It's a crucial step that will determine whether we can truly become a spacefaring civilization, capable of reaching new worlds. With this capability, the boundaries of exploration expand dramatically. The moon, Mars, and even the outer planets become reachable, transforming what was once science fiction into tangible reality. The next era of lunar exploration begins with a daring maneuver in Earth orbit, a bold step toward fulfilling humanity's oldest dream, to journey beyond our world and explore the vastness of space. Why is refueling in orbit so critical? For decades, the dream of exploring the moon, Mars, and beyond has been limited by one stubborn problem: fuel. Rockets are massive, but most of their size is just tanks filled with propellant. Once they leave Earth, they're nearly empty, unable to go much farther. So, how do we break free from this limitation and truly open up the solar system? The answer lies in the rocket equation, a fundamental law of physics that dictates how much fuel a rocket needs to escape Earth's gravity. The more fuel you carry, the heavier you get, and the more fuel you need just to lift that extra weight. It's a vicious cycle. To reach the moon, a fully loaded Starship simply can't carry all the fuel it needs from Earth in one go. The rocket would be too heavy to launch and the payload would shrink to almost nothing. SpaceX's solution is both bold and elegant. Launch multiple Starships, each carrying only fuel, to meet in orbit and refuel the main lunar vehicle. The primary Starship, destined for the moon, waits patiently in low Earth orbit, nearly empty, conserving its precious fuel for the journey ahead. Specialized tanker Starships, stripped of unnecessary equipment, rendezvous with the lunar Starship and transfer their fuel in a delicate ballet of orbital mechanics. This process is repeated, sometimes requiring a dozen or more tanker launches, until the lunar Starship's tanks are finally full and ready for the next leg of its mission. Orbital refueling is the key that unlocks Starship's full potential, allowing it to bypass the limits imposed by the rocket equation and carry massive payloads far beyond Earth. This approach transforms the economics and logistics of deep space travel, making missions that once seemed impossible suddenly within reach. With a fully fueled Starship, the full payload capacity can finally be delivered to the Moon, Mars, or even more distant worlds, opening up new frontiers for science and exploration. This revolutionary concept is what makes ambitious missions, like building lunar bases or sending humans to Mars, practical and achievable for the first time. But while the idea is simple, executing it is Starship's greatest hurdle on the path to the lunar surface. The challenge is immense, but the rewards could redefine humanity's place in the cosmos. Imagine two colossal vehicles, each over 1,000 tons, docking in space. The tanker Starship performs precise burns to approach the lunar Starship. Using thrusters, it aligns perfectly for docking. The final approach is slow, ensuring a flawless connection. Once docked, the critical phase begins, transferring propellant. Super-chilled liquids move via pressure differentials, a delicate process. After transfer, the tanker returns to Earth, leaving the lunar Starship ready for its voyage. Transferring cryogenic propellants in orbit is a monumental leap. This process involves moving extremely cold liquids, like liquid oxygen and liquid hydrogen, from one spacecraft to another, while both are in the vacuum of space. The ability to refuel in orbit extends the operational range of spacecraft, allowing for longer missions and more ambitious exploration goals. SpaceX must write the rulebook for handling these powerful, efficient fuels. This involves developing new technologies and protocols to ensure the safe and effective transfer of cryogenic propellants. Engineers are meticulously designing systems to manage the extreme temperatures and pressures involved. Cryogenic propellants provide more thrust but are challenging to manage. These fuels are kept at temperatures hundreds of degrees below freezing, and any exposure to heat can cause them to boil off rapidly. This makes insulation and temperature control critical. Materials must withstand intense cold, and boil-off is a thermal challenge. Engineers are testing various materials and insulation techniques to minimize heat transfer and prevent the loss of these valuable propellants. In zero gravity, liquids behave unpredictably, complicating transfer. The lack of gravity means that liquids do not settle at the bottom of their containers, making it difficult to pump them from one tank to another. SpaceX will use thrusters to settle propellants and develop reliable pumps. By firing small thrusters, they can create a small amount of artificial gravity to help move the liquids into the right position for transfer. Mastering this process is key to unlocking the solar system. With the ability to refuel in space, missions to Mars, the Moon, and beyond become more feasible, opening up new frontiers for exploration and potential colonization. It creates a foundation for interplanetary logistics. Establishing a network of refueling stations in orbit could support a continuous flow of missions, making space travel more sustainable and routine. Any destination becomes reachable with enough tanker flights. By strategically placing refueling stations, spacecraft can extend their range and reach distant destinations that were previously out of reach. Early test flights gather data to tame these cryogenic fluids. Each test provides valuable insights into the behavior of these propellants in space, helping engineers refine their systems and improve safety. Each flight is a step towards routine orbital refueling. As SpaceX continues to test and develop these technologies, the dream of a fully operational orbital refueling network comes closer to reality. SpaceX's Dragon spacecraft has honed orbital rendezvous skills. Dragon's precise docking with the ISS informs Starship's development. This experience provides a head start for Starship's docking challenges. At SpaceX's Starbase, innovation moves at a staggering pace. The mantra, build, fly, learn, repeat. Rapid production supports the orbital refueling architecture. Multiple launch pads enable quick tanker turnarounds. Starship version 3 will be taller, lighter, and more capable. Iterative design solves complex problems at unprecedented speed. Leaders instill a culture of ambition and urgency. They build a transportation system for humanity's future in space. Progress accelerates towards routine orbital refueling. Mastering orbital refueling is crucial for NASA's Artemis mission. A fully fueled Starship can deliver habitats and infrastructure to the Moon. It transforms lunar presence from visits to sustained habitation. For Mars, orbital refueling is essential for a crewed mission. It allows for a large habitat and supplies for a self-sustaining outpost. SpaceX's leadership sees challenges as solvable engineering problems. They attract bright minds to create a spacefaring future. Successful cryogenic refueling marks a turning point in history. It creates a logistics network for the solar system. Space becomes accessible and affordable, empowering bigger dreams. The quest to refuel Starship fuels humanity's future.